We're getting ready to move into verifying trig identities. In preparation for that, we're going to start off with some simplification. We're going to simplify trigonometric expressions. We're going to use our fundamental identities, which we've touched on in the past. I don't think we've hit all of them. Our fundamental identities are the reciprocal identities, which we've talked about. These are just the identities saying that sine theta is the reciprocal of cosecant theta, and vice versa. And cosine theta is the reciprocal of secant theta. And again, that's the same relationship both directions. Tangent theta is the reciprocal of cotangent theta, and the other way around. We also know our quotient identities, where tangent theta is sine over cosine, and cotangent theta is cosine over sine, because they're reciprocals of each other. The Pythagorean identities we will touch more before our next lesson, but and I'll go through where those come from. One other thing we're going to use in this section are some of the properties of even and odd functions. We've talked about these in the past as well. And that's the fact that because sine, cosecant, tangent, and cotangent are all odd functions, that means that if we negate the input, for example, if we take a theta, negate the theta, the impact it's going to have on the output is that it's just going to negate the output. So for example, if I have sine of something equals 1/2, sine of negative of that thing is going to be negative 1/2. And the same goes for tangent. Tangent of 45 degrees is 1, and so tangent of negative 45 degrees would be negative 1. Even functions, however, if we negate the input, it has no impact on the output. In other words, cosine of 60 degrees is going to be the same as cosine of negative 60 degrees. And the same goes for secant. So let's use this information. I put this in as a sheet that you should be able to see and print. Let's use this information to simplify some fundamental identities. There are lots of ways of going about this. Sometimes it's helpful to rewrite the expression in terms of sines and cosines. Other times it's helpful to notice things like, since tangent and cotangent are reciprocals of each other, then it would make sense, I hope, that cotangent of theta times tangent of theta would be 1. Just like if you had 2 times 1/2. These are reciprocals of each other, and anytime you have reciprocals, they will multiply to give you 1. So we'll take advantage of all of this information as we try to simplify these. I have sine x and secant x, and right now I don't see anything I can do with these two. However, I do know that secant is the reciprocal of cosine. So that means this is sine x times the reciprocal of cosine x, which would be sine x over cosine x. And a way to simplify this, to write it in one term, would be to recognize that this is the same as tangent of x. So secant, or sine x secant x, is the same as tangent x. We've simplified this expression. How about tangent x cosecant x cosine x? That's a mess. Let's see. Well, we have a cosine here, and we have the reciprocal of sine there, and we have sine over cosine. So let's just write it all out and see what happens with this. So tangent x is the same as sine x over cosine x. Cosecant x is the same as the reciprocal of sine x. And cosine x, we'll just leave it alone for right now. And at this point, we can divide out a sine x from the numerator and denominator, divide out a cosine x from the denominator and the numerator, and in all of these cases it leaves behind a 1. And when we multiply across, we get 1 over 1 which is just 1. So all of this mess and all of this mess simplifies out to just 1. Tangent theta, cotangent theta, sine theta. Well, we just set up here that cotangent theta, tangent theta is 1. So we could simplify this to 1 over sine theta very quickly. And there is a single expression we can use that represents 1 over sine theta, or it's equivalent to 1 over sine theta, and that would be cosecant theta. So again, this is a simplified version of the earlier expression. Cosine negative alpha, cosecant negative alpha, secant negative alpha. Alright, so apparently the negative, that's going to bring in the even and odd properties. So let's remember back, cosine is an even function. So that means that cosine of negative alpha is the same as cosine of positive alpha. Cosecant is the reciprocal of sine. That's an odd function, meaning that cosecant of negative alpha is the same as negative cosecant of alpha. And secant of negative alpha, again, secant is a reciprocal of cosine. So if cosine's even, secant must be even. So that again gives us the relationship that secant of negative alpha is the same as secant of positive alpha. Alright, so we have a positive, a negative, and a positive, so our final answer is going to be a negative. And if we look at this, cosine and secant, those are reciprocals of each other. So cosine of alpha times secant of alpha, that's going to be 1. Or if you need to see it written out, cosine of alpha times secant of alpha is the same as cosine of alpha times 1 over cosine of alpha. So again, that's going to be 1. So combining the cosine and the secant gives me a 1. And then that just leaves behind this cosecant alpha. So our final answer, negative 1 times cosecant alpha, is just negative cosecant alpha. One final problem. This one looks kind of big and ugly, but there are 4 terms, we can handle it. Sine of negative beta, cotangent beta, secant negative beta, tangent beta. First thing I'm seeing is that cotangent beta times tangent beta is just going to be 1. So we can think of this as sine negative beta times secant of negative beta. And using our even and odd properties, sine of negative beta would be negative sine of beta. And secant of negative beta, well, that's an even function, so it's just going to be plain old secant beta. But secant beta, that's 1 over cosine. So this is sine beta times 1 over cosine beta. Or you could look at it as negative sine beta over cosine beta. And as we remember from our our quotient identities, that is negative tangent beta. Again, the negative is just going along for the ride. Nothing about the sine over cosine is what made this negative. It was just the fact that sine is an odd function, meaning the negative on the inside changes the output.